In 7.2, we are talking about properties of exponential functions, so graphs with exponential functions. First, knowing what an exponential function looks like. The exponential function is always going to have a parent function of this. Now, the b can change, so the b will determine what the parent function is. So in this picture, 2 to the x is my parent function, and then this 3 in the blue times 3 is going to be the transformation that happens. So in this picture, when we're talking about exponential functions, we're going to care about how does this point change. That's going to be the points that will always have to be on your graph when you're graphing these problems. And then explaining what is actually going on. So this 3, since it's larger than 1, it's going to be a stretch. And we'll get into all of the formats in the next slide. Boop, boop. And make sure to write this down so you have a reference. Now again, the parent function depends on the b. If a is going to be greater than 1, it's going to be a stretch. If a is greater than 1, it's a stretch. If a is less than 1, it's going to be a shrink. And all you will have to say is stretch or shrink. Now, if a is going to be negative, if a is negative, it's going to have a reflection over the x-axis. That's always going to be the case. And then we have inside and outside the function. Now, if we have an h, so if x is being added or subtracted to, it's going to move either left or right. And just like how we've talked about before, on the inside of the function, so anything that's happening to the x, it's always opposite. So if it says x minus 2, it's actually going to the right 2. If it says x plus 2, it's actually going to the left. And this right here is going to be your vertical shift, either up or down. Now, one thing to make perfectly clear is when I have two graphs, a parent function, depending on what b is, if I have 2 to the x compared to 1/2 to the x, if I'm going to have this number, if b is going to be a whole number, like a number on your number line, 2, 3, 4, things like that, it's going to have the shape like this somehow. Now, if the number here is going to be less than 1, if b is less than 1, then it's going to have a reflection over the y-axis. It's going to flip it. Reflection over y-axis. I would make sure to write that down as a reference. If b is less than 1, it's going to be reflection over the y-axis. Now again, on these problems, you can use your graphing calculator to help you. Let's get to it. So for these type of questions, this format will always be the same. I'll always have this stuff over on the left for you to fill out. First, explain your transformation. It might be helpful to first pick out what's your parent function. In this case, my parent function is 3 to the x. Now, the other stuff is going to do something to it. So this negative is going to give me a reflection over the x-axis reflect. This 1/3 is going to give me a compress. So now I've stated the two things that are happening to this function. Now, like I said before, if you put 0 into the function, that's the point I'm looking for. When you put 0 into the function, what comes out? Now, in this case, when I put 0 into the function, I would get that this here is going to become 1, so this would become a negative 1/3. Because again, you're putting 0 into the function, and that's going to be the point. So I'm going to change that point. At 0, I go down about 1/3, and I'm going to plot that right away. Horizontal asymptote. If I were to graph my parent function, my point would be at 0, 1, and I would go about like this. I would have a horizontal asymptote at 0 because of the fact that it can never go past 0. Now, this does not change my horizontal asymptote, and it's going to say y is equal to 0 because it didn't move up or down. There's no transformation up or down. And my shape is going to compress. So it's going to compress here. So compressed means that it's just going to get a little wider. So I'm just going to draw it a little wider compared to my parent function. And my range is always what can y be equal to. So I'm going to write my y. And you use your horizontal asymptote. So in this case, it's 0. But y is not equal to that. Y is going to be less than 0. You do not put the or equal sign for all of these range. You do not put the equal sign. So this number right here is always going to be the same as your horizontal asymptote. So I'm going to go over this again. First, I'm going to pick up my parent function. Now, looking at my parent function, since b is less than 1, this is going to reflect over the y-axis. So I'm first going to just plot that point. This point on your parent function never changes. So it's going to look something like this. So again, this is your parent function. How does this change now? So again, this is my parent function, so anything that's not circled, I have to explain. So this number is greater than 1, so it's going to be a stretch, a large stretch, and this is going to be up 10, because it's outside the function. So how does my point change? Well, my point at 0, again, the point is always going to be when x is 0, what's y? Y is going to be equal to 30. How do I get that? Again, you plug it into your equation. So this does not change, but now you're plugging 0 in for x, and if you plug that in, you'll get 30 out. Your horizontal asymptote is going to move up 10 because of this right here. So I'm going to have my horizontal asymptote at y equals 10. And then my shape, it gets stretched. So it's getting skinnier. Now your range is going to be y. If you want to graph this first, you always can. It's going to be greater than, because it's not flipping at all. So it's a greater than. And again, this number is always your horizontal asymptote. There's no equal sign. So if I graph this, now I'm going to say that this is going up by tens because I have very large numbers. First, I would graph my point, which is right here. So 0, 30, and I'm going to label that. I have a horizontal asymptote at y equals 10, so that's a dotted line. Again, each box is going to be 10. And then my shape is a stretch, so it's getting very skinny. So that would be a great graph for this function. I want you to pause the video. Yes, pause the video and try to do all these steps by yourself, making sure to fill out all the points.